Everybody, and welcome to science class. My name is Mrs. Portella and I will be your teacher today. I'd like to talk to you about what you're doing today. We're doing another function carnival. This time it's velocity. And you may have noticed this week that velocity is a little bit more difficult than a distance time graph. I've gotten a lot more questions from students, and I think we still have a lot of students who are a little bit confused out there. So I want to go ahead and just clarify before this starts. This is going to be probably a little bit harder than the last one you did. P.S. Remember, I can see everything you do on here, so if you're skipping things, don't. Stop that. Please. Just don't. Anyway, here's our class code for this one. I'm going to go ahead and join. Welcome to the Function Carnival. Continue the activity. Yay, me. Okay, you hit play. Some of you weren't exactly matching. I can tell you that about, of the 125, roughly 60 of you completed this well in the last time we did this. I'm going to go ahead and just hope that more of you will do better this time. But I totally understand if it's difficult, then just shoot me an email. Let me know. Join one of our Zoom conversations where I've been trying to walk people through things. I'd love to help. This arrow, by the way, super helpful because it tells you where to start your velocity. So, if I were to start drawing, let's say, what's he doing? I'll play it again, and I'll walk you through this one. I'll just answer this one for you. Okay? We see the guy get shot out of the cannon, and then he hits the parachute and slows back down. If we were to go ahead and start this again, remember, he shoots out of the cannon. He is currently going away and slowing down, so it's a positive velocity, getting closer to zero. And at that moment right here, roughly, this one he switches and he starts coming towards and speeding up. So it's at this moment that he's at zero velocity. Let's see if we got the timing right. That's pretty close. Then he's coming back towards until right about here. We'll mark that. That's when the parachute happens and he starts coming towards at a slower velocity. So the question is, if we start here and we're going to get slower going away, we're going to want to, I'm just going to use a straight line. That was pretty horrible. Apologies. Straight line. Okay, we'll go something like this. Let's take a look, see how we did. That's pretty close. We went a little too fast. So maybe we want to, oh no, I just got rid of my line. Sadness. Let's try this right here. That's pretty good. Then we're going to keep going down until we get to the point where the parachute opens, which is about right there. So let's make this line continue on down at the same slope, because remember, you're accelerating due to gravity. So your acceleration doesn't really change. But we can talk about that next week. Let's start it over. Let's see how we did. Following, okay. It's coming down, a little bit behind, and that's when the parachute's got to open. What's going to happen when the parachute opens? I'll leave that one to you. You can finish the rest of this. The goal is, remember, you want to try and match the green parachute guy as close as possible. Okay, same thing with this. You want to try and match this green car as much as possible. Some of you are like trying to avoid the cars or something, avoiding a crash. No. Just mimic what's happening with a green car. Okay, and then the last one is my favorite. You have to figure out the velocity of this roller coaster car. It kind of helps by spacing out these little green dots here, so you got an idea of how fast it's going by how close the dots are. So just kind of use that to your advantage. This is the screenshot I want you to turn in. Okay? When you're done with this one and you think you nailed it, take a screenshot of your graph and turn it in. That's all you got to do for this lesson. Let me know what questions you have, and looking forward to talking with you soon. Goodbye now.